Welcome back to ECG Basics. This time we're going to be focused on the rhythm. Hopefully you've watched at least the introductory lecture that gave the kind of basic outline for what we're doing in these lectures. We're looking at a simplified systematic approach to looking at an ECG and coming up with a final interpretation, but we want to go through step by step along the way so that we don't forget anything or miss anything that might be important. So the last lecture we looked at the rate. This time we're going to look at the rhythm. If you remember, the 6 steps are rate, rhythm, axis, intervals, hypertrophy, and infarction. So this is 2 out of 6 parts that we're looking at. Okay, so once you figure out the rate, which we did in the last video, and you decide if it's sinus rhythm that's in the normal range, or if it's tachycardia or bradycardia. Perhaps you've given a name to the rhythm already based on the rate. However, when you come to the second part of this systematic approach and you're looking at the rhythm specifically, the first question to ask is this rhythm regular or irregular? And we touched on this a little bit in the last lecture. When we say regular, what we mean is the distance between the R waves is either on the whole the same or seems to be changing beat by beat. So for example, if you look at the picture that we have here on the left, if you took the R waves and you just kind of measured the distance. Now you can measure them if you want, but most of us will just kind of estimate from looking at it. The distance between these R waves and these R waves and these R waves, they seem pretty much the same. So we would say that this is a regular rhythm here. On the right-hand side, we could do the same thing. We could pick these R waves here. We say, okay, we've got that distance, but look what happens at the next one. It's a much shorter distance. And then we come to the next one, and it lengthens out again. We get to the next R to R distance, and it's the longest one yet. So you can see that this distance and this distance and this distance, none of them are the same. It's constantly changing from R wave to R wave. So we would say that this is an irregular rhythm. And that's really the first step, because when we break up different types of rhythms, they're going to be based on whether they are regular or irregular. And then from there, we can look at some other patterns. Once you determine if it's regular or irregular, the next question really is about the P waves. So you want to ask yourself 5 questions about the P waves. The best place really to look for P waves is going to be lead 2, and that just has to do with the way the electricity flows through the heart and the way it's recorded on the ECG. That lead 2 would be the best place to find P waves. Other leads are also helpful, but we would say lead 2 is probably the best place to look. So particularly if you have a rhythm strip, as we do on this one, that is lead 2, that's the best place to look to answer these questions about the P wave. So the 5 questions would be, are the P waves consistently present? So that means, can you, with fair certainty, look at the rhythm strip and say, it looks like there are P waves there most of the time? I mean, really, you want all of the time. And what I'm showing you in these lectures, I'm hand-picking ECGs. They're a little bit easier to read. But when you start reading actual ECGs, you'll see that to say always or never can be a little bit tricky. And so I would say, generally speaking, are P waves consistently present? Now on the one that I've given you here, we should be able to find the P waves pretty easily. So there's a P wave, there's a P wave, P wave, P wave, P wave. And if we went down the line, you would see that every beat has a perceptible P wave. And so you would answer yes to the first question, are P waves consistently present? The second question would be, do the P waves generally look the same? Are they the same height? Are they the same width? In general, do they look the same? And again, you could look at this ECG that we have, and you could see that these P waves generally look the same. And the reason I use the word generally is if you look at this P wave and this P wave, you might say, oh, well, this one here is not as tall, it's shorter, it's flatter. And that's true, but look at the next one, and the next one, and the next one, and the next one. In general, they all look the same, right? So don't get hung up on one or two beats that you think don't fit the pattern. Generally speaking, these P waves look the same. Okay, the third question would be, is there a P wave before every QRS complex? So here's a QRS complex, and there's its P wave. Here's a QRS complex, and there's the P wave. QRS, P, QRS, P, QRS, P. And down the line, you would see that in this example, yes, there are P waves before every QRS complex. Now, the fourth question, the next question, sounds the same, but it's not, and it's important to get the distinction. So question 3, is there a P wave before every QRS complex? What you're looking for are QRS complexes that stand alone with no P wave before it. Question 4, is there a QRS complex after every P wave? What you're looking for are P waves that stand alone. You have a P wave, but you have no QRS that follows. So in question 3, you're looking for lonely QRSs. In question 4, you're looking for lonely P waves. So slightly different. And again, if you looked at our rhythm strip on lead 2 here that we have, you would see that every P wave is followed by a QRS, and every QRS is preceded by a P wave. So the answer to both of those would be yes. We have no lonely P waves, and we have no lonely QRS complexes. Okay, the last question is the PR interval consistent? That means the distance between the end of the P wave and the beginning of the QRS complex. Is that distance the same, or is it changing? So for example, here we have a very small PR interval. I mean, it's actually 40 milliseconds. It's very quick. And a normal PR interval, we'll talk about this later, would be less than 200 milliseconds. So this is not only normal, but it's consistent. Look at this one. Very short, very short. The distance between the end of the P and the beginning of the Q is roughly one small box, maybe 1.5 small boxes, and it's consistent. It doesn't change. So we would say yes to that. So there should be a question mark. So in the example that I've given you, we said yes to all of these. And really, if you say yes to all of these, you have normal sinus rhythm. And this normal assumes that the rate is normal, so it's not bradycardic or tachycardic. So you might better just say you have sinus rhythm. So if you answer yes to all of those, you have sinus rhythm. And typically sinus rhythm, even if it's fast or slow, you can come up with some physiological reason or medication reason for that, and it's not an actual internal problem with the heart. Okay, so what I want to do through the remainder of this lecture really is just practice these two things that we talked about. First is determining if the rhythm is regular or irregular by looking at the distance between the R waves or the S waves and seeing if they're consistent or not. And once you determine regular or irregular, then going through those 5 questions about the P waves. And by doing that, we're going to be able to separate really almost all of the common rhythm problems that you are going to see with just really these 2 simple approaches. So if we look at this ECG that we have, the first question would be, is it regular or irregular? Now, just to show it a little bit differently, instead of measuring the R waves, let's look at this rhythm strip of V1, and let's measure the distance between the S waves, right? Notice there are no Q waves, and the R waves are so tiny that you really can't see them. So let's measure the distance between here and here, here and here, here and here. And you can see that's kind of long, that's short. That one's maybe even longer than the first one. This one's even longer still. Then we get back to a kind of a medium. So the point being that even without measuring specifically, you can look at this and generally say, yeah, the distance between the QRS complexes is changing. It's not consistent. So we would immediately say that this is irregular. Okay, so it's irregular. Now let's go through our P wave questions, right? So the first question was, are P waves consistently present? So we're going to look at lead 2 for this, if possible. So let's look at this QRS. Is there a P wave? Not really. There's a couple of squiggles here. Not sure if those are P waves. So there's a T wave there. There doesn't seem to be a P wave in front of this QRS. There's another squiggle, but it doesn't seem to be related to that QRS. There doesn't seem to be any P waves there, no P waves there. So we would actually answer no to the first question. No, there do not appear to be consistent P waves. Now, we're going to teach an algorithm here in a little bit. Once you really reach that no, there are no, that it's irregular and there are no P waves, you're actually pretty much done with the rhythm. If you have an irregular rhythm and there are no consistent P waves, you're talking about atrial fibrillation, which is what we have here. And one of the reasons that you stop here is because you can't do some of the other questions, right? Is there a P before every QRS? Is there a QRS after every P? Well, there's no P waves. Is the PR interval consistent? Well, there's no P waves. So if there's no P waves, you really can't continue your 5 questions. If there's no P waves and it's a regular rhythm, then we have some other options, and we'll talk about those later. But this is one of the easiest rhythms to identify, because if you meet these 2 criteria, irregular, and there are no consistent P waves, your answer is pretty much atrial fibrillation. You'll also hear people talk about this kind of rhythm as irregularly irregular. And what that means is there isn't any kind of pattern at all. There's not a pattern where it's like short, short, long, short, short, long, short, short, long. It's just all over the place. Like we said here, this was kind of long, short, long, even longer, medium. There's no pattern there. The irregularity doesn't have a pattern. It's actually irregularly irregular. When you see that, you know that it's atrial fibrillation. This is super common rhythm, especially in older individuals. The older you get, the higher the incidence. Okay, now let's look at this one, and let's go through really our 2 sets of questions. The first question is it regular or irregular? And so we're going to look at the distance between the R waves, right? So there's that. That's kind of long. That's a little bit shorter. Excuse me. This distance may be similar to the second, but definitely shorter than the first. And then we get long again, and then we get maybe even a little bit longer. If you're not sure, you can always actually just measure the distance between the R waves and get an actual number. But I can tell you from looking at these lines that this is not regular, that the distance between the R waves is changing beat to beat. Okay, so we have another irregular rhythm. And I'm not sure why the pen has stopped working. What's the deal there? Okay, so sorry, I had a little problems with the pen. We're talking about that this rhythm was irregular. So that's kind of the first step. So now we need to go to our 5 P wave questions. So 1, are P waves present consistently? So if you're looking along at this rhythm strip, you would say, well, that's a funny looking P wave, but it's right before the QRS, so that's probably a P. That's probably a P. That's probably a P. I don't know what's going on here. It's going down, but I don't know, maybe that's a P. That looks like a P, that looks like a P. So you say, yeah, and I mean, I have a question about maybe one of them, I'm not sure, but I think in general there are consistent P waves. So you would say, yes, there are P waves. And then the next question would be, do the P waves look the same? Now this is where we might get into some trouble, because you're looking at these P waves and saying, well, this one is kind of tall and skinny. This one's kind of smaller and a little more rounded. This one is, I don't know if that's part of it or if it's just that. This one looks all down, maybe a little hump up there, I don't know. This one looks even shorter than number 2. This one is tall but wider than number 1. And so you're starting to get the idea that whatever's going on here, these P waves, they really don't look the same, do they? So you would say, no, the P waves do not look the same. So now that you've come to an answer that's no, you know already that this is not sinus rhythm. This is some other rhythm besides sinus rhythm. So we're going to continue with our questions, right? The next question is there a P wave before every QRS? And we just looked at that. There's P waves before every QRS. You'd say yes. Then you would say, are there QRSs after every P wave? You would say yes. So there's no lonely P waves and no lonely QRSs. And the last question is the PR interval the same? So is that interval and that interval and that interval and that and that and that, are they the same? And I would say in general, yeah, this one here looks a little closer, but it's hard to know where the P wave ends there. In general, they're very short P waves. They don't seem to be getting longer or changing distances considerably. So I would say, yeah. So our only no here is, are the P waves the same? Do they look the same? So when you get kind of all yeses except for this one being no, except for the P waves being changed, remember that the P waves are atrial depolarization. So they should all be coming from the SA node, and they should all be looking the same in sinus rhythm. But if you have P waves that are looking different, that means you're actually getting signals from different parts of the atria instead of just the SA node. And so we call this multifocal atrial, and it tends to be fast tachycardia. So, or we call it MAT for short. We don't have enough probably rhythm strips here to see if this is truly tachycardic, but this is 300, 150, 100. So there's about 100 here. It's about, let's see, 300, 150, about 130 here, about 140 here. So it is tachycardic, and if you counted it for 10 seconds, you'd be able to get the overall heart rate, but you can see that it's running fast. So this is a tachycardia, and because the P waves are changing, it's atrial because there's P waves, right? That's what P waves mean, atrial depolarization. So we know that the rhythm is coming from the atria, but instead of coming consistently from the SA node, which would give you a P wave that's the same shape and size, we're actually getting different shapes and sizes of P waves. So we have multifocal atrial tachycardia. Okay, here's 2 ECGs, and it's because they show variations of a similar problem. So we'll work through them one at a time. But I put them on the same slide because they're kind of grouped together. So let's look at the top ECG first, and we're just going to go through our questions. So the first question is it regular or irregular? So if you look at the distance between those R waves and those R waves, that's fairly similar. But then you get to this one, and it's much shorter, you can see. Then you get to this one, and it looks longer than even the previous ones. And then you get to this one, and it kind of looks like the first one. So it's not regular, right? It's changing. We don't have enough of a strip to know if it's irregularly irregular, like atrial fibrillation, or if there's some kind of pattern here. But at this point, we can say it is definitely irregular. Okay, so then we're going to go through our P wave questions, right? We have 5 of them. First question is, are there P waves? And we would say, oh, that looks like a P, a P, a P. That's probably a little P there too. Right there. P wave, P wave. So we would say, yes, there are P waves too. Do they look the same? In general, yeah. I mean, you're not supposed to get super picky. You're just supposed to kind of eyeball it and say, are they about the same shape and size? They're all kind of small and rounded. So I would say, yeah, they are just about the same shape and size. Okay, is every P wave followed by a QRS? So there's a P with a QRS, 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 P with a QRS, P with a QRS. So we would say yes, there are no lonely P waves. And 4, are there any lonely QRSs? So do any of the QRSs come without a P wave? So there's a QRS, there's a P, QRS, P, QRS, P, QRS, P. So they all have, they're all coupled up with a P wave. So we would say yes. There's a P wave before every QRS, and there's a QRS after every P wave. And the last question, is the PR interval changing? So there's the PR. They're all pretty short. That one's maybe a little longer. But in general, you would say, yeah, in general, the PR intervals look pretty much the same. So we would say yes. Okay. So remember, if you've got all yeses, you're going to say, well, this is sinus rhythm. So we've got some kind of sinus rhythm, but it's an irregular rhythm, right? We're used to seeing a regular sinus rhythm. Here we have an irregular sinus rhythm. And actually, that's the name of it. We call it a sinus arrhythmia, because the impulse to beat is still coming from the sinus node, so that's normal, but it's not regular as we expect. So we want to come up with a reason why. We want to find out why is it that this, what should be a normal rhythm, because it's sinus, is actually irregular. And if you're looking at this, you might be able to eyeball it and say, well, let's see, that kind of looks the same, that kind of looks the same. The problem seems to be somewhere in here. We've got a really short and a really long. And you might notice that, you know, there should be some distance between the T and the P, right? Look at the distance between the T and the P. And all of a sudden, the T and the P, that distance is tiny, tiny. It's almost like this heartbeat came early, right? It was premature. And that's exactly what we would call it. This is a premature complex. Sorry, ran out of space there. A premature complex. And what kind of complex? Where is it coming from? Well, we think it has a little P wave there. So that's a atrial complex. So we say that's a premature atrial complex, or a PAC. So you just had an extra, you had an atrial beat that escaped sooner than it was supposed to. It came early. And what you'll often see is when you have a premature complex, you then have a longer kind of T to P interval on the next beat. So you have a short followed by a long, which is what you see here. So this is nothing to worry about. We see these all the time if you take ECGs or look at people's rhythms, and it's really nothing to worry about. You might even feel them yourself sometimes if you feel like your heart did a couple of beats in a row or something. But there's no danger there, so we wouldn't worry about that. Okay, let's go down to the bottom ECG, and we'll ask the first question, is it regular or irregular? Now, my eyes are drawn to these 4 in the middle, and they look very regular. The distance between those looks very regular. However, between this one and this one, and this one and this one, they're quite long. So technically, you would say this is irregular. Okay, so then we have to go through our 5 questions about P waves. So the first is, are there P waves? Well, let's see, that's a T. So that's probably a P, that's a T. And then we've got this funny QRS complex. So there's no P wave there. There's a P wave, there's a P wave, P wave, P wave. There's a T, I don't see a P wave there. And this P wave is hard to see, but I bet you it's in there. That's probably it right there. So this is a difficult one to answer. How I would answer this is that yes, because in general, right, we have a couple of places where we're not sure we see P waves, but in general on the rhythm we see fairly consistent P waves. Technically, if you want to say no there, that's fine, but you're going to have to answer the rest of the questions since you are seeing P waves, unlike AFib where there are no P waves. Okay, so for the sake of our questions, let's say that yes, there are, in general, consistent P waves, even though we have a couple of places where we're not sure. Then we would say, do all the P waves look the same? They're all kind of short and flat, right? So yeah, don't get too picky over the exact shape and size, but in general, they're all kind of short and flat. So we would say, yeah, in general, they all look the same. Number 3 would be, are there P waves before every QRS? So we've kind of been going through this already, but if you just kind of scan it, there after every P wave is a QRS, and then we would ask the same question kind of in reverse. So there are no lonely P waves. We're looking for lonely QRSs. Are there any QRSs that are not preceded by a P wave? And here we would say, well, these funny looking, right? This is a QRS, but it's really strange. It doesn't look like the other ones. And here's another one. And we really don't see a P wave there, right? These are kind of lonely QRSs. So I would say the answer to that one is no. Every QRS is not preceded by a P wave. We have at least 2 examples of QRSs that do not have preceding P waves. So that may be the clue to figuring out what this rhythm is. Okay, 5 is the PR interval consistent? So very short, very short, very short, very short, very short. Yeah, they're consistent. The PR interval is consistent. Okay, so we are really focused on these 2 abnormals, aren't we? This is where the problem seems to be. Everywhere else it looks like sinus rhythm, but we have these 2 funny looking QRS complexes. And because there's no P wave, they are not sinus, right? They're not coming from the atria. They're not atrial beats. They're coming from somewhere else. We'll also notice, and we'll talk about this more later, this QRS, right? This QRS complex is very narrow, maybe at most 2 small boxes, a box and a half. This QRS complex from here to here is very long. So we'd say this is wide. This is a wide QRS, and this is a wide QRS. We'll come to the exact definitions of that in a later lecture, but for now I think you can appreciate just from looking at it, these look skinny and those 2 look wide. Okay, so we have a wide QRS that has no P wave. That's going to tell us actually that these originate in the ventricle, right? If they originated in the atria, there would be P waves. Because there's no P waves, it has to come below the atria. If it was coming from the AV node, they would be narrow complex. We'll talk about that later. So the fact that they're wide complex and there's no P wave means that they are ventricular. And once again, look at how it seems to come early, right? It should have waited that distance before you had your next beat, but it came early. It's another premature. So this is another premature complex. But we just said it's not atrial, like this one was premature atrial, right? Because there was that P wave there. This is going to be a premature ventricular complex. And actually, you have 2, right? You have 1, 2 premature ventricular complexes. Remember, you know they're ventricular because there's no preceding P wave and they are wide. So this is also a very common thing that you see on rhythm strips or on ECGs. Again, not anything that we worry about if there's just kind of a few of them or they pop up every now and then. If they start occurring in succession, like you get 3, 4, 5, 6 of them in a row with no normal beats in between, that usually means that you have an irritated heart and you're at risk for a more dangerous type of rhythm that we'll talk about later. But these are very common. They're actually sinus rhythms, right? If you take those premature beats out, everything else is normal sinus rhythm. Here what you're getting is sinus rhythm that's been interrupted by these premature complexes, either coming from the atria or coming from the ventricles. You can also get premature kind of AV node or junctional complexes that look very similar to the PACs, except they don't have any P waves either. Okay, so let's look at this rhythm. And remember, the first question is it regular or irregular? So let's look at the distance between